Hello 108 class, Mr. McCue here, back on section 1.1. Okay, looks like I have to turn this toolbar on every time. Sorry about that. Okay, working on section 1.1, continue it, and we're going to do page 2 now. Okay, objective number 3 talks about different types of common sets of numbers and real numbers here. This is a summary of what we just talked about before here. So get comfortable knowing that our numbering system started off with, I think, humans. As we were out there and learned to count animals, we started to come up with natural numbers or counting numbers. And so we start them off with 1, 2, and 3. Again, the notation is the brackets, left bracket, right bracket, list the elements. The 3 dots tell you that they go on forever in counting fashion. Okay, so now you've got counting numbers. Then we got down into whole numbers. Whole numbers are nothing more than 0 being added, and then you add the natural numbers. So keep in mind, natural numbers are a subset. They're within whole numbers. Now watch how this keeps building up here. Look at integer numbers. Now we're using the letter I for integer, W for whole number, N for natural numbers. And now integers we talked about are your positive counting numbers, which are going 1, 2, 3 and forever. 0, which consists of the whole number. And finally the negative counting numbers, -1, -2, -3, and they go on forever towards infinity, and that would be your integers. Okay, so those are your basic dollar bills, is how I like to look at it out of my wallet. And then we talked about rational numbers. You know, the books love to write things in symbolic forms. They use the letters P over Q. It's just telling you it's a fraction. Can you write the number as a fraction? And P and Q are integers. When you can, then it's a rational number. Think of does it make sense? Irrational numbers are ones that do not make sense, and they cannot be written as the form of a fraction. And again, we talked about pi being 3.14. It's an irrational number because when they took that ratio, it goes on forever and ever and never repeats. Okay, finally, real numbers. This is what we're really getting into here for this objective number 3. Basically, real numbers are all of x such that x is a rational number or an irrational number. And that's all the numbers that we know right now. Okay, so with that said, some of you will be comfortable getting these our common sets of numbers, real numbers, rational numbers in this notation. Some of you might like figure number 4. If you're a visual person, you might like to see there's the natural numbers are the inner core numbers. They're counting. Whole numbers added to 0. Integer numbers added the negative counting numbers. Finally, rational numbers are all of these numbers plus any fractions or any decimals that can be written as a fraction. So those are the ones that we think of most of the times in our daily lives. Irrational are the ones that don't make sense. Notice here that square root numbers, you cannot come up with an exact number that multiplied by itself gives you 2. It turns out to be about 1.41, but it goes on forever and never repeats. However, the square root of 9 is a perfect square root because positive 3 or negative 3 multiplied by itself will give you a positive 9. So these are not irrational numbers because the result is a whole number. Okay, so keep those in mind. One of the examples we like to work with is give you a bunch of numbers going across in a set and ask you to identify which ones are integers, which ones are rationals, irrationals. And so what I like to do is you just start from left to right and ask what's -8, and it's an integer number, it's a counting number. How about other counting numbers? I see 0 and I see 2. So these are the ones I would list. Rational numbers, can you put them in the form of a fraction? -8, yes. -9/64 is already a fraction, so you list it. Okay, the square root of -5, rational numbers, square root numbers almost always are irrational unless they are a perfect square, such as the square root of 9, which is 3, or the square root of 25, which is 5. Okay, so you work your way down. You list anything that was an integer has to be part of the rational numbers. 1/3 is a fraction. How about this? 1.12. When you see 1.12, that means the 1, 2 repeats forever and ever and ever. Okay, now that is considered a rational number. Okay, if you see the repeating bar, and that's what this means up here, they are considered rational numbers. Irrational numbers are the ones that don't make sense. The square root of -5 would be an example. I'm looking for the square root of 3. That's not a perfect square. And there's pi, which we've already talked about before. Okay, finally they say part D, come up with all real numbers. Well, that's all the elements that are in the set. That's how you would answer that. So you list them all. Okay, one last objective here to round out page 2. Objective 4 talks about additive inverse. This simply means take any number, and if you have a number such as 5 and you add its opposite like -5, you will always get 0. You could do it the opposite way. If I give you -9 and I go add what's the opposite of it, opposite of -9 is a +9, add them up and you come up with 0. And that's because if you owe somebody $9, you pay them back the $9, you're even. Same thing over here. If you've got $5 in your pocket and you go to Sonic, which I like to go to a lot, and you get yourself a limeberry cream slush and a little treat, it's $5. You pay it off and you paid off your bill. Okay. Keep in mind also here a multiplicative identity inverse. Take a number such as -5, multiply by its opposite. Negative times the negative is a positive, and a -5 times the -1 will also give you a +5. Okay, so that wraps up page 2 here, folks. I will see you for page 3.